Since the beginning of time, we have looked into the stars and asked, what is out there? And who else is out there?
That's a wonderful epic voice.
Thanks, man. I've been trying for 3 days to nail it.
3 days for the epic voice.
Epic voice is like what makes the entire podcast, man. It's most important.
It's very important. It is very important.
The most important.
I'm Noah Cyclopon.
I'm Gavin Navarro.
Let's talk about Fermi's paradox. So why don't we talk about Fermi himself before we talk about his paradox?
Well, Enrico Fermi, the person who invented this paradox, was an American-Italian physicist. He got his degree in physics from the University of Pisa.
You mean Pisa?
But he's Italian. You know, Italian pizza.
Not everything Italian is pizza.
But Italian pizza.
We're talking about Fermi.
Okay, sorry. He was awarded a Nobel Prize in 1938 for demonstrating the existence of new radioactive elements. Fermi is also known for leading his team to create the world's first self-sustaining nuclear reactor, the Chicago Pile 1 in 1942.
Well, that's great and all, but I actually want to talk about his lunch.
His lunch? I think you're confusing this with Isaac Newton. You know,
Newton Big Bars? What?
No, the famous scientist who invented gravity. You know, apple fell on his head.
Yeah, no. I want to talk about this guy's lunch.
But what?
Hear me out.
Okay.
I'm going somewhere with this. So, in 1950, Enrico Fermi was sitting and he was talking with a bunch of his friends, eating lunch, and he says to his friends, imagine if intelligent life developed on a planet. If this society was to evolve in a similar rate to our own and start developing a lot, it theoretically would only take a few 100 million years for them to begin colonizing other planets and start exploring space. And when you think about it, that isn't really that long of a time period. The universe is plenty old enough, and theoretically, lots of these civilizations should have appeared by now.
Well, if they have all this time, they could have created this technology to communicate with us. And if they haven't, where are they?
And that's exactly the paradox. The universe is plenty old enough and plenty big enough, so where is everyone?
Well, let's start off with saying, what are the chances of life actually forming?
Well, you have a good point. To be honest, the chance of life actually forming is pretty low. We were lucky and we got this great blue jewel of a planet that happened to be in exactly the spot we need it to be. Exactly the amount of distance it needs to be from the sun. It happened to have an atmosphere, it happened to have water, and everything was just right for us. And so life formed. And scientists are still kind of iffy about, the chances. So even though this happened to us, what are really the chances of it happening in other places? But let's go back for a second. Let's pretend that somewhere out in the universe, life does form. What's stopping that life from developing into the point that Fermi was talking about? What's stopping them from 100 million years from now turning into that civilization that starts colonizing other planets?
Well, there's always going to be great filters.
You have a point, considering there are nukes.
Okay, no.
I want to talk about nukes, though.
No, define great filters first.
Okay, well, great filters are basically events that happen throughout a society's history. As a society grows and things happen, there are going to be points where you either get past your obstacle or you don't. And for us, that's nukes.
Okay, but what if these extraterrestrial beings don't have nukes?
Well, the thing is, nukes. Just think about it for a second here. Our great filter right now is actually nuclear warfare. We're at a point right now where there are things going on in the world, and one of the biggest problems is the chance of someone just casually dropping a nuke on us. And if that happens, if a nuclear war does start happening, there's actually a really high chance of the human population in general just to go extinct. And as a society grows, even on another planet, we have to assume that if they can get past the earlier filters, they'll eventually reach the point where they understand fusion reactions and start making nuclear warheads.
Okay, let's say that they also handle this filter better than us and eventually surpass it. Are they going to hit another one?
Of course, there's always going to be more filters. We don't know what they are because obviously we're still stuck on this one, but there's a possibility of resource deficits. There's the possibility of overpopulation. That's another great filter that could be hitting us pretty soon, if not hitting us right now.
So, let's say that these extraterrestrial beings do get to the point where they surpass their filters. The distance between them and us is also going to be a major factor that prevents us from actually communicating. See, Mars, just going to Mars alone is 54.6 million kilometers away from us, which is, in retrospect, about 300 days to get there. So, imagine having to go all the way to, say, the other side of the galaxy. And that is light years away from us. So that's going to take even more time than just traveling to Mars. And that's already difficult enough. So communicating through distance and space is something that we have to further evolve to eventually be able to communicate with potential extraterrestrial life.
And the thing is, even if we can evolve and develop, it's kind of a fact that the fastest you can go is the speed of light. And even light takes a long time to go from one end of the universe to the other. And I mean a long time. So even if somehow, going against the laws of physics, we are able to go as fast as the speed of light, it'll still take forever to get anywhere. So the point is, even if there is another alien civilization out there, what are the chances of us being able to communicate with them? We can't even send radio signals that far. And even if they get there, then it'll be years after we sent them. One interesting topic to think about is Bracewell von Neumann probes. And Bracewell von Neumann probes are basically a possible solution to this distance problem. They're basically a concept where you would send out a probe that is able to self-replicate. So it would go out, collect materials from, let's say, nearby meteors or asteroids. They would collect this material and then make more of itself in order to keep going and going and going. This way, it would theoretically be able to get to the other end of the universe because it wouldn't run out of resources. However, there are still problems with this because, again, it would take a long time for it to go anywhere, even if it is able to go anywhere.
So, what if aliens actually do get to the point where they can communicate with us? How would they actually do it? How would their language be different from ours? How could they actually communicate with us through math and science?
That's actually really interesting because the way we grow up, everyone around us communicates in pretty much the same way. We may speak different languages, but we speak a language. We talk using our mouths. Even other than that, we know how to use sign language. We know how to write. We know how to read. But it's entirely possible that extraterrestrials would not know how to do this. They might have evolved to communicate in a different way. I know it sounds kind of crazy to believe, but we don't know what kind of conditions that they're growing up in. Their planet could be completely different from ours, just same in that it can support life.
Well, wouldn't there be a way that we could translate how they're talking to us?
Well, that just kind of depends on how exactly they are communicating. But the problem is, for all we know, they are already trying to communicate with us, but we just don't know it. If we don't know, then how can we translate?
That's a good point. And that brings me to say, what if aliens are actually really close to us and not far away? Like they're watching us and they're seeing what we're doing, but we can't see them.
So like in Hitchhiker's Guide to the Galaxy.
Yeah, zoo theory.
Exactly. If you haven't read the book Hitchhiker's Guide to the Galaxy, it's really interesting in that it proposes that the human race and the Earth in general was created as kind of an experiment, basically. It's a lab. And humans are the lab rats. And in this theory, the humans have no idea that there are aliens, and it's only until some crazy guy decides to blow up their planet that they do realize. My point being is that, for all we know, we could be in one of these quote-unquote zoos, that there are aliens around us that are observing us, but we just don't know. The problem with this is, if even one of these aliens decides to be humane, in a way, this theory would be completely overturned because an alien would just come down and say, hey, this isn't right, you should go free, and we would know by now. It only takes one of them for this entire thing to go astray.
Okay, so let's just not. Okay, so is there like an equation that can just tell us the probability of all this happening?
You sound kind of tired, Gavin. You all right there?
This is just there's all this theories and sciencey stuff. This is oof.
Well, speaking of oofs, there is the Drake equation. It's theoretically, well, it's basically an equation that calculates the number of communicating civilizations in our galaxy. The thing is, though, there's a lot of open-endedness in this equation. It's not very precise. It's not very, to be honest, it's not very helpful at all. And honestly, it's kind of become the laughingstock of of everyone who studies the Fermi paradox. So most scientists who study possible solutions to the Fermi paradox don't really care about the Drake equation.
Speaking of not caring, what if aliens just simply don't care about communicating with us?
I mean, you have a point. It's entirely possible that aliens somehow have the ability to communicate with us, and they may even know about us, but they just don't care. And if they don't care, then we can't really do anything about that, can we?
Well, I mean, we could force them, like, we force most of our wars, like,
I don't think we can force a highly evolved alien civilization. I think that's just going to cause, like, Galaga or something.
Well, Galaga was a good game.
I don't think I want the Earth to be destroyed today, Gavin.
Then it has to beat the bosses!
Okay.
Well, okay, so, obviously we don't want Galaga. That's just gonna make everything scary, make everything panicking on Earth. But we also don't need to add that to the universe. The universe itself is just really scary. I mean, a whole bunch of black holes, a whole bunch of just stuff that could hurt us, like meteors,
asteroids. Gamma ray bursts. Believe it or not, gamma ray bursts don't turn you into the Hulk. They'll most likely evaporate us and the entire planet if we get hit by a direct impact at a close range.
You literally just ruined my plans for this weekend.
Yeah, it probably ruined the aliens' weekends too. I mean, yeah, like you said, the universe is a pretty dangerous place. Even if aliens did exist at one point or another, they could have easily been destroyed by gamma ray bursts or some random meteor or black hole, anything like that. To be honest, it's kind of funny that we survived.
Hold up, okay. How is that funny?
Oh, I mean, like, in retrospect, I guess.
So you mean ironically?
Yeah, ironically. Let's go with that.
Okay, yeah. So if these aliens were or did happen to be destroyed by some random dangerous thing, how old can our universe actually be?
Well, it's funny that you asked that because the universe is actually really young. Scientists these days estimate the universe to have a lifespan of quite a few trillion years. So in the span of it all, the universe is actually still basically a toddler. Like, it has a long time to grow. And when you think about it, it's kind of cool that we even appeared at this stage of the universe's life. Like, we possibly may even be the first intelligent life forms to be born in this universe. The planet Earth might have been the first planet to have just the right conditions for intelligent life to develop. And that's a weird topic to think about because this entire time we've been thinking about it the opposite way, the way that Fermi thought about it. He said that the universe is already so old, it's already at a point where there should be so many things just running about, but there isn't. There's just us. And we won't know if there's anything else. Not until an alien mothership just comes down from the skies or stealing our cows or something.
Really? That's how we're supposed to know?
Yeah.
Not like them just coming down and shaking our hands.
No, they will steal our cows.
But what if they just come down and shake our hands?
They will steal our cows and they will ask us to take them to our leader.
I mean, if that's how you want to put it, okay.
The point is, as of right now, there isn't really a true solution to Fermi's paradox. And over the years, lots of scientists and just regular people have thought about it and found all of these great different theories and conspiracies and possibilities. And honestly, any of one of them could be true. We won't know until we see an alien, until they steal our cows.
Will you stop talking about cows?
I will never stop talking about cows.